So the last time we met in lesson 4.5, we were factoring polynomials, whether it was a binomial, a two-term polynomial, or trinomial, a three-term polynomial. And we used either greatest common factor between all the factors, or we grouped them up and into 2 to 4 pieces each, and then found the GCF of each group. All right. What we're going to cover today is a circumstance when we have a trinomial where neither GCF nor grouping may work. Okay, so we're working on factoring trinomials in lesson 4.6, and we're continuing with our essential question on what are the different methods for factoring trinomials. This is the third of 5 ways of factoring trinomials. And the learning target that we're going to be focusing on is I can factor trinomials by using what's called the AC method. Some of our vocabulary that we've still been continuing to use: binomial, trinomial, polynomial, degree, factors, perfect squares, and we'll talk about greatest common factor from time to time. All right. So say we have this quadratic trinomial. Essentially, it's going to make a U shape if we ever graphed it, but in this case, we are just going to sit there and factor it. All right. And then we have our example right here: x squared plus 4x minus 32. Now, if you notice, we can't use GCF because not all 3 terms have a common factor we can pull out. And we can't exactly group it because we could group it like that, but that leaves the constant by itself. So that we can't do that. Grouping is more used with even amount of terms, not an odd amount. So anytime you have a trinomial, a 3-term polynomial, all right, you're going to use what's called the AC method. What you're going to do is you're going to find 2 numbers that add together to equal the middle coefficient. All right. So you're going to find 2 numbers that add up to add or subtract to equal that, but also multiply together to equal that. One of the easiest ways to figure out what those 2 numbers are is to simply list all the factors for C and then figure out which 2 factors have a difference of 4. Okay, so let's list all the factors of 32. Okay, so we have 1 and 32. All right, 2 and 16. 3 can't go in it. 4 can, and it multiplies with 8. 5 can't go into it because it doesn't end with a 0 or 5. 6 can't get into it. And then 7 can't go into it. So our factors are 1 and 32, 2 and 16, 4 and 8. Now, what we have to do is figure out which of these 3 sets of factors either add up or have a difference of 4. Okay. So if you notice, 32 is a negative number, which means one number will have to be positive, one number will have to be negative. Okay. And because the middle is a positive, the bigger number will be positive and the smaller number will be negative. Okay. So with that in mind, let's take a look at our 3 sets of factors. So looking at 1 and 32, if you look at the difference, 32 minus 1, that gives you a difference of 31. Looking at 16 and 2, that gives us 14. And if you look at 8 and 4, that gives us 4. So out of these three sets, 4 and 8 seem to be our two factors we're going to use. And if you recall what I said earlier, 32 is a negative number, so one of the numbers has to be negative. And to determine which one's going to be negative, you look at the middle number here. And since it's positive, the bigger number will have to be positive, which is 8. And the smaller number will be negative, which is 4. Okay? And because we have x squared, we give each of them an x. So our two factors for x squared plus 4x minus 32 are x plus 8 times x minus 4. Okay? X minus plus 8, x minus 4. And to check to see if they are truly the factors, all we have to do is just distribute everything out. All right? Or we can use what's called the FOIL method. So first terms, outside terms, inside terms, and the last two terms. So x times x gets us x squared. X times negative 4 gives us minus 4x. 8 times x gives us a positive 8x. And then 8 times negative 4 gives us a negative 32. And then we simply just combine like terms. There's only one x squared, so we rewrite x squared. Negative 4x plus 8x results in a positive 4x. And then we just bring over negative 32 because it's the only term. So folding it out or distributing the two terms amongst one another results in x squared plus 4x minus 32, which is the same thing as what we started with. So these are truly the two factors that we have. Let's take a look at another example. We have x squared minus 7x minus 18. Okay, x squared minus 7x minus 18. So what we're going to do is we're going to find all the factors of 18 and figure out which two have a difference of 7. So all the factors of 18. 1, 18. 2, and 9. 3, 6. 4 can't go into it, 5 can't go into it, and we use them. So that's the three factors that we have. 1 and 18, 2 and 9, 3 and 6. Now, I'm going to go ahead and get it already set up. All right. This is similar to this problem. So x squared minus 7x minus 18 is similar to this. So we can go ahead and set up our two factors, x plus and x minus. All right. So x plus, x minus. So we just got to figure out what the two numbers are. Now, if you look at it, negative 18, or we have 18 is negative. That's why one of our numbers has to be negative. However, the 7 is negative and not positive. Or, all right. So the bigger number this time will be negative, and the smaller number will be positive. So let's look at of all the differences. 1 and 18 gets us a difference of 17. 2 and 9 gets us 7. And 3 and 6 gets us 3. So 1 and 18 is not it. 2 and 9 seems like to be it. 3 and 6 can be it. So our two factors, our two numbers we're going to use for the factor is 2 and 9. The larger number is 9, so it's going to be negative. And the smaller number is 2, so it'll be the positive number. All right. And to check to see if we actually did this right, we're going to distribute our two factors with one another. X times x times x, x squared. X times negative 9, negative 9x. Negative 2, or my apologies, positive 2 times x results in a positive 2x. And 2 times negative 9 is minus 18. Now we combine like terms. There's only one x squared. -9 plus 2 gets us a -7. And -18 is our only constant, so we bring him over. And if that matches what we started with, then these two are our factors. Okay. Now we're going to take a look at one that if our first coefficient, our biggest variable, if it has a number that's not 1. All right. In this case, we have a 2. What we start off by doing is dividing everything by 2. All right. Then repeating the process from example F and example E. Okay. So I'm going to divide everything by 2. 2x squared divided by 2 gives us x squared. Plus 12x divided by 2 gives us positive 6x. Positive 10 divided by 2 gives us plus 5. Okay. And what we do with the 2 is we put a set of parentheses around our polynomial and we slap 2 on it. All right. Because if we distribute this 2 amongst our polynomial, if we did 2 times x squared times 2 times 6x, 2 times 10, it would come back to this. But let's just focus on x squared plus 6x plus 5. All right, so we're going to list all the factors for 5, which in this case, there's only one set of factors, 1 and 5. Okay, and they do in fact add up to 6. Okay, so we're going to get our 2 sets. And since this is positive and this is positive, both these would be positive. Does not matter where we put our numbers. You can do smallest, biggest. You can do biggest, smallest. Whatever you decide on doing. Just remember, because we started with a 2 up here, you put 2 at the front. All right. And what you do to check is you multiply the 2 factors in the middle first, then distribute the 2 with everything else. All right. So that is it for factoring trinomials. All right. Using what's called the AC method. All right. Next time, we will be focusing on if we have a binomial and the multiple ways that you may have to deal with that.